Hello children, welcome back to my channel Matrices Fun. So today we are going to study the chapter of matrices which is there in class 10 ICSE boards. So let us first know what the matrices means. Matrices, how do we represent matrices? Matrices means it is the rectangular arrangement of numbers in the form of horizontal and vertical lines. Like if we see like this, how do we represent matrices? In the third bracket we write the numbers. Suppose we are writing 2, 3, 5, 7. Okay, so we can see here it is in the form of 2, 3 is in the form of, these are either in the vertical or the horizontal lines, isn't it? These are called the rows and this one the columns. This is the row and this is the column. Okay, so each of these horizontal lines are called rows and these are called columns. So the numbers are arranged in rows and columns. Okay, and these are the elements inside the matrix. We use generally matrices to solve simultaneous linear equation. So here we will study about matrices. Next we will know the order of a matrix. Suppose consider a matrix with the elements 2, 3, 5 and 7. See here the number of rows are, see we can see that 2 rows are there. This is the first row and this is the second row. And also we can see that there are 2 columns, isn't it? So if there are m rows and n columns, then we write it, order of matrix will be m by n. This is not the multiplication sign. It is said that m by n. M represents the number of rows and n represents the number of columns. Okay. So here we can see that here 2 rows are there. We can see 2 rows are there and 2 columns are there. So order of the matrix, this matrix will be, suppose if you name it as A equals to, order of the matrix A will be equals to 2 by 2. I hope it is clear. It is 2 by 2. Again, if there are elements like this, see here there are 1, 2, 3 rows are there and only 1 column is there. So here as we say that said earlier that m by n, m represents the rows and then n represents the column. So how do we write here, how do we represent this matrix? Suppose this is B, so order of B will be equals to 3 by 1 because there are 3 rows and only 1 column, so it will be 3 by 1. Now we can see that in this matrix A, here there are 4 elements, 1, 2, 3, 4. Now if we want to represent or if we want to see the position of this element, then how do we write? We write it by I and J. Ith and Jth means, I means this is the first, it is in the, this, if you see that this one, this number 2 is written in the first row and also in the first column. I represents the row and J represents the column. So position of 2 will be, it will be given by, you can say that I and J. So here it will be in the first row and also in the first column. Now if we say that this one 7 is there in the, see it is in the second row and also in the second column. So it will be 2, 2. We write it like this. The element 2, 2th is 7. Similarly, if we write 3, it is in the first row and in the second column. So it will be first row and second column. The element will be 3. See, first row and second column. So I hope it is easy to understand that ith and jth column. I am giving you one more example. Suppose A equals to maybe 2, 3, 5. Okay, So what is the order of this matrix? The order is, how do we write it? Like this. Order of matrix A. Order of matrix A is equal to, see here there is one row and 1, 2, 3 columns. So it will be 1 by 3. Okay. Now if you represent this element, we want to know this element. That means it will, if we write it by A, ij. Suppose if we represent the elements by A, ij. So it will be A, I for this is the only one row is there. This is the first row, only one row. So it will be 1, and j means it is in the second column. What is the position of this 3 element? Ij means this is in the first row and in the second column. A, 1, 2. The element will be 3. Next we move on to the types of matrices. How many types of matrices are there? Let's see. First is row matrix. Row matrix, as the name suggests, it will consist of only row. Like 1, 2, 3 maybe. Then is the column matrix. Column matrix means a matrix having only one column is called column matrix. 1, 2, 3. See, it has only one column. If it has one row, that means row matrix. If it has one column, that means column matrix. Next comes the equal matrices. Two matrices are said to be equal if the elements are same inside it and also their order is same. That means, suppose we consider A and B, two matrices. Suppose it has 1, 2, 3, 4 and it also has 1, 2, 3, 4. See here, both the matrices A and B have the same elements in the same position also. Here the position, here it is 1 and in the first column and first row and first column, here also it is 1. All the positions are same and also it is a 2 by 2 matrix and it is also a 2 by 2 matrix. So these two matrices are equal. A will be equals to B. Okay. But if we rearrange the position, suppose it is 3 and it is 2, then these two matrices are not equal. They are not equal because all the elements are not in the same position. Here it is, we have changed this position, so it is not equal. Next is zero matrix. If in a matrix all the elements are 0, all its elements are 0, then it is called a zero matrix or null matrix. Then comes the identity matrix. What is that? Identity matrix means the diagonal elements will be 1 or unit and the rest will be 0. This diagonal elements will be 1 and the rest elements will be 0. This is a 2 by 2 matrix, 2 by 2 square matrix. Acha, what is square matrix? Square matrix means here, as in a square, what we see, in a square all the sides are equal. So here it will be 2, here also 2, 2 by 2. Not like this. See, this matrix is not a square matrix. Why? Because it has only one row and 3 columns. So it is 1 by 3. When the number of rows and number of columns are same, then it is called a square matrix. Like this is a matrix of order 2 by 2. 2 columns and 2 rows are there. 2 rows and 2 columns. So it is 2 by 2. And so it is a square matrix. In a square matrix, if the diagonal elements are 1 and rest of the elements are 0, then it is called, diagonal means like this. These two positions will be 1 and these two will be 0. Then it is called a identity matrix. Again, you can also see a order 3 by 3 matrix like 1, 1 and 1, and these positions will be 0. It is of order 3 by 3, as you can see. there are 3 rows and 3 columns, isn't it? So it is an identity matrix of order 3 by 3. So we are moving on to the exercise 8.1. I am doing this sum. Find the values of A, B, C and D if A plus B 3, 5 plus C, AB equals to 6, D minus 1, 8. I am doing the sum from ML Agarwal chapter Matrices, exercise 8.1. It is new edition. Okay. So it is given that the matrices, I am writing it here, the solution. First A plus B, and here it is given 5 plus C, 3 AB is equals to 6. Then here it is D and minus 1, 8. See, we can see that the order of this matrix in the left hand side and right hand side both are same. Here it is 2 by 2 and here also it is 2 by 2. Since both of the matrices have the orders are same, 2 by 2 and 2 by 2. So we can say that A plus B, here the first element A plus B equals to 6, should be equal to 6. Since it is given that these two matrices are equal, their orders are same, so A plus B will be equal to 6. First condition. Second is D will be equals to 3. We are getting it directly. D will be equals to 3. Then 5 plus C will be equal to minus 1. Okay, and AB will be equals to 8. So these are the conditions we can get. Okay. Next we will solve it. 5 plus C equals to minus 1 means C will be equals to minus 1 minus 5, that is equals to minus 6. So we have already got C. C and D we have already got it. We have to find out A and B. So here it is given A plus B equal to 6 and AB equals to 8. So we can do it by substitution method. Like suppose we are considering here from here we can see that, suppose if we say that A will be equals to 6 minus B. So we will put this value of A here. 6 minus B into B equals to 8. See, from here A equals to 6 minus B, we are putting this value in this part. AB equals to 8. So 6 minus B into B equals to 8. That means 6B minus B square will be equals to 8. We are getting a quadratic, right? Which implies minus B square plus 6B minus 8 equals to 0. Then we can write it like this: B square minus 6B plus 8 equal to 0. If you take the minus sign common, okay. Let us do middle term. See, 6B is there. Here it is 8B square it will be. So 8B square means we can do it 4 into 2 equals to 8 and 4 plus 2 is 6. Minus 4 minus 2 minus 6B. So it will be, if you take B common, then it will be B minus 4 to B minus 2 into minus 4 plus 8 equals to 0. It will come as B minus 4 into B minus 2. So we are getting two values of B. Either B will be equals to 4 or B will be equals to 2. So either B minus 4 equals to 0, so B equals to 4, or B minus 2 equals to 0, B will be equals to 2. So we are getting B4 and B2. So for two values of B, we will get also two values of A also. Because A was our 6 minus B, isn't it? So A will be equals to 6 minus B. First we are taking B equals to 4. So 6 minus 4 is 2. Then again we are taking B equals to 2. Then it will be 6 minus 2, that will be equals to 4. So here we are seeing the answer. A will be equals, A has two values, either 2 or 4. B also has two values, 4, 2. C has only one value, we have already taken out, -6. D will be equals to 3. So this is our answer. Next we will discuss about the addition and subtraction on matrices. Addition and subtraction are only done when the two matrices, we can add them only when they are of the same order, or we can say that if they are compatible, right? Like if A equals to, suppose we are given a matrix, suppose it is 2 3 1 2. B equals to 3 2 1 0. See here both of them have the same order, 2 by 2 matrices. Then we can add them. If we add them, it will be A plus B. How do we add? What is the rule? We have to add with the first row and first column, this one. This element will be added to this one. That is, first row first column element will be added to the first row first column element of the second matrix. That is, here it will be 2 plus 3. Then here it will be, this will be added to this. That means 3 plus 2. This one and this one, 1 plus 1. And then 2 plus 0. So we are getting it as 3 plus 2, 5. So this is our answer. Similarly, if we consider these two matrices and we have to subtract these two matrices, A minus B, then it is again the same process is there. Same elements, first row first column element will be subtracted from this first row first column element of this B, that is 5 minus 3. Here it will be 3 minus 2 minus 1 minus 1. Okay, A minus B, since we are doing A minus B, we have to follow this order, this and this. First we have to write the elements of A, then the elements of B. Minus 1, then 2 minus 4. So it is coming as 3 minus 2 is 1, minus 2, minus 2. I hope it is clear, the addition and subtraction of matrices. Next is, if we multiply a number with a matrix, like suppose a matrix is there, A equals to 5, 6, 7, 8 maybe. Okay. So now if we are multiplying this matrix, suppose with K, or suppose 2 into A. So we are multiplying this 2 with this matrix A, right? Each element of this matrix A will be multiplied with 2. Means 2 is multiplied to each element of this matrix, like this. 2 into 5, 2 into 7, 2 into 6, 2 into 8 will come as it's quite easy, very easy, isn't it? Now we will see some remarks actually given in the book. You can see, if two matrices are there, A and B of the same order, then A plus B will be equals to B plus A. First is, if we add two matrices A and B in this order, A is first A and B, if you are like suppose 1 2 3 4, A is 1 2 3 4 and B is suppose 1 5 2 3. So if we add A plus B, it will be same as B plus A. A plus B will be equals to B plus A. That means this is, the addition is commutative. This is commutative law. Addition is commutative in matrices. Then it is also associative. Associative means A plus B. If we add, if three matrices are there, A, B and C, then A plus B plus C will be equals to A plus B plus C. You have to follow this and apply in the questions in your exercise. Then number 3 is, if a zero matrix is there, means a square matrix added to the zero matrix will be equal to 0 plus A. Zero matrix should always be of the order, same order as A, this matrix. If it is a square matrix, this zero matrix should also be a square matrix with order 2 by 2. Both should have the same order, then only we can add. So A plus 0 matrix will be equals to this 0 plus A matrix, 0 matrix plus A. Then number 3 is, 4 is A plus of negative of this matrix. Suppose here it is A, minus A will be, all the terms will be negative. Minus means the sign will change actually, all the elements. When we put A and minus A plus minus A will be equals to 0. Zero matrix. Okay, not 0 actually, but the zero matrix. We are moving on to exercise 8.2 of matrices from ML Agarwal, and I am doing this question number 3. It is given that simplify sine of A into, this is sine of A into this matrix, sine A cos A minus cos. So this is our question. It came in 2019. So how do we solve it? First we write sine A into this matrix and cos A into this. As it is, this is k into this matrix and k into this. Here k is in the form of sine A and here it is cos A. So we are multiplying it, sine A into sine A, sine square A, sine A into minus cos A, minus sine A cos A, sine A into cos A, sine A cos A, sine A into sine A, sine square A. Plus, here it will be in this matrix, cos A into cos A, cos square A, cos A into minus sine A cos A, cos A into sine A cos A, and cos A into cos A, cos square A. Right? Then what we will do? We are adding these two matrices. First we multiply it with this sine A, then we will have to add these two matrices. So with the first term, as the rule of the addition is, first this one with this one, sine square A plus cos square A. The element of the first row and first column with the first row and first column of this matrix. Then here it will be minus sine A cos A plus here it is sine A cos A. Minus sine A cos A plus sine A cos A. We will find it at 0 here, isn't it? And here it is sine square A plus cos square A. If you have done identities, you must know sine square A plus cos square A is 1. We will do it later. Let us first write the last two, add the last two terms. Sine A cos A plus minus sine A cos A. Sine A cos A. Here it is sine A cos A and here it is minus sine A cos A. Because it is plus of minus will be minus. Plus into minus, minus. So we are doing it as minus. Here again sine square A plus cos square A. This term sine square A plus cos square A. So this will come as, the matrix will come as like this. Here we can see that sine square A plus cos square A, it will come as 1. Isn't it? Then it will become minus sine A cos A plus sine A cos A. It will become 0. Again here sine A cos A minus sine A cos A. Again it will be 0. And sine square A plus cos square A, it will be 1. So we can see that it is coming as one identity matrix of order 2 by 2. Isn't it? See, identity matrix, diagonal elements are 1 and the rest are 0. So it is coming as identity matrix of order 2 by 2. So we have to see, in the question we have to find out, simplify, just we have to simplify and find out the matrix. So this is our answer. So after that we are including this sum also. Find x and y if x plus y equals to 70 and x minus y 7025 and x minus y equals to 3003. We have to find the matrix x and matrix y if the sum of the matrix x plus y is this, and after subtracting the matrix x and y we are getting this. So we have to find the matrix x and y. So let us see the solution, how to do it. See, we can do one thing. We can add these two matrices. Let's see what happens. Adding matrix, this is, if you consider this as 1 and this matrix as 2, then we can say that adding 1 and 2 we get, what do we get? Let's see, x plus y plus x minus y. So x plus y matrix is 7025 and x minus y matrix is 3003. Here in the left hand side we will see that left hand side, see, x and this is x, means it will become 2x and this will cancel out, matrix y plus y and minus y, so it will become 0, equals to, if we add this to matrices, what will be the value? We have to add this first to this, 7 plus 3, here 0 plus 0, 2 plus 0 and 5 plus 3. So it becomes 7 plus 3 10, 2 plus 0 is 2, 0 plus 0 0 and 5 plus 3 is 8. Now what we will do, here it is 2x plus 0, means it is actually 2x matrix only. Then what we will do, see, here it is x. We have to find the matrix x and this is a constant 2. If we put it, if we can just put it here, it will become 1 by 2. So it will become 10 by 2, 0 by 2. Means since it is 1 by 2, we have to 1 by 2 into 10, 2 by 2 into 10, this 1 by 2 into 0, 1 by 2 into 8. So it will become 10 by 2, 0 by 2, 2 by 2, 8 by 2. 10 by 2 means 5, 2 by 2 means 1, 0 by 2 means 0 and 8 by 2 means 4. So matrix x equals to this. First answer we got. Now to solve y, what we will do? We will do subtracting. We have to subtract these two, x plus y and this, expression 1 and expression 2. So it will become x plus y, matrix x plus y minus, since it is becoming minus, we have to put bracket x minus y equals to, the right hand side, it is 7, 0, 2 and 5 minus 3, 0, 0, 3. So what do we get in the left hand side? We see that x and this, see, x plus y minus x plus y equals to, here what do we find? 7 minus 3, 7 minus 3, 2 minus 0, 0 minus 0 and 5 minus 3, right? Then here it becomes, see here x and x means it will become 0 matrix. X minus x is 0 plus y is 2y. So it is 7 minus 3 means 4. 2 minus 0 is 2. And 0 minus 0 is 0. 5 minus 3 is 2. Okay. Next we see that 0 matrix plus 2y means 2y matrix. 2y equals to 4 0 2 2. Then it is becoming what? Y equals to, same like the previous, we have taken out x, same way it will become 1 by 2, and here it becomes 4 0 2 2. So it becomes 1 by 2, sorry, we have to write like this, y equals to 4 by 2, 2 by 2, 0 by 2 and 2 by 2. So our matrix y becomes 4 by 2 means 2, 2 by 2 means 1, 0 by 2 means 0 and 2 by 2 means again 1. So we have already found out x in previous part, and now here y we got 2 0 1 1. Okay. So I hope the chapter of matrix is a bit clear to you, and we have included few sums, but I hope it is clear to you, the chapter. In a new video, we will discuss about the multiplication of the matrices. So thank you. Please don't forget to share and subscribe to this channel for more videos.